And what does that represent? It always makes, yeah, it's always positive. It gives the distance to 0. So basically, whatever you put in, it just gives you back a positive answer because the distance is always positive. Okay. So what we have to be able to do is take an equation or an inequality and write it without the absolute values in order to solve it. So let's kind of talk about these properties of absolute values. For equations, if I said the absolute value of A equals B, that means that A could equal B, or A could equal negative B. Okay, if you think about what that says, if I said like the absolute value of X equals 2. So that means on a number line you have to be 2 away from 0. So that means you could be at positive 2 or you could be at negative 2. Both of those are a distance of 2 from 0. If I put absolute values on both sides, it still means the same thing. Either those two numbers are equal to start with, or they are opposites of each other. So it doesn't matter if your absolute value is on one side or both, you're just solving two equations. All right, inequalities. We have to pay attention to less than or greater than. If I say the absolute value of A is less than B. So for instance, if I said the absolute value of X is less than 2, that means my distance from 0 has to be smaller than 2, right? I'm going to go back to that slide in just a second if you didn't get it right down. So that means the distance would be less than 2. That would be everything up to 2, but it could also be everything down to negative 2, right? So it's just in between those two values. So this means negative B is less than A is less than B. Did Mrs. Keller say like less than an and statement? So that means you have one big inequality. So that works when you have the absolute value on the left and your other expression on the right. If I said greater than, so kind of think about it. If I said the absolute value of X is greater than 2, that means you have to be more than 2 away from 0. So you could be bigger than 2, or you could be smaller than negative 2. Both of those are more than 2 away. So in this case, we have A is greater than B, or A is less than the opposite of B. When you do the negative one, you flip that inequality. Did she write it like this, or did she do a compound inequality? Do you guys remember? Kind of went both ways. Okay. So what you guys need to remember, this is like great or, it's an or statement, so you have this or this. When we solve those great or thans, we're going to get 2 intervals for our answer. The and, we're going to get 1 interval. Okay, so once we write the problem without the inequality, or without the absolute value, then it's just like the equations that we've been solving. So let's just practice. That's the idea. Now we're going to apply it in some examples. So let's solve these equations. So for this one, what would my two equations be? So we set it equal to a positive 7 and a negative 7. And then we just solve those. So let's subtract my 9. Negative 4x equals negative 2. Divide by negative 4. X is 1/2. The other one, if we subtract our 9, divide by negative 4, we get x equals 4. Can you check these? Yeah, always. Plug them back in, put in a half, 9 minus 2, the absolute value is 7, put in a 4, absolute value of negative 7 is 7. So it works. Let's do another equation. This is the one where I tend to see more mistakes. So the first one, you just drop the absolute values. So 3x plus 2 equals x minus 5. People tend to mess up on the second one when they do the negative because they write it like this. 3x plus 2 equals negative x minus 5. What's wrong with that? I want to do the opposite of that entire thing. So you have to distribute that negative here. So then if I solve these, subtract my 2, subtract my 5. Divide by 2, so we get negative 7/2. Add my x, subtract my 2. Get 3. And of course we can always check these just by plugging them back in. So far so good? You need to be careful if I give you something like this. I cannot just set this equal to positive 8 and negative 8. Why? Isolate that absolute value first. So we can subtract the 4, divide by 2. Once that absolute value is by itself, that's when you can make your two equations. So we get x equals 5, positive. If I had made this, I gave you a problem. Next value of x plus 6 equals negative 7. Why? Yeah. You could solve this. You can set it equal to positive 7 and negative 7 and get two answers. But when you plug them back in, they don't work. You would get 1 for one of your answers, but when you put it in, does the absolute value of 7 equal negative 7? No. Absolute value is always positive, so can it equal a negative? No. So anytime you have these absolute values, whether it's an inequality or an equation, if you have a negative on one side and absolute value on the other, you need to stop and think about it. In this case, absolute value can't equal a negative, so it's no solution. We don't have to solve it. Let's look at some inequalities. I mean, if you want to go see if you're supposed to be on.
He's probably waiting for us right now.
Sorry, I was waiting for an announcement. But I've been waiting and I haven't seen it. Wondering. Okay, so I have my absolute value by itself. This is a less than. So is that an and or an or statement? And. So for the and statements, you put it in between the negative and the positive. And so then we just solve this compound inequality. So if we subtract the 1,
Please dismiss cross country at this time. Please dismiss cross country.
can you just watch the video to get the assignment? Okay. And then divide by 2. Now, I don't want you to write it like this for your final answer. What do I want you to write? The interval. This one, it's everything between -4 and 3. When it's an and, you're going to get just a single interval like this.
Okay.
All right. Is that okay with everybody? Is that how you did it last year? Did she separate the two inequalities? Do you want me to do it that way, or is this okay? No. This is all right? Okay. So let's look at the same thing, but if I made it a greater than, and see what changes. So what I like to do when I see and, I like to just keep it together because I know it's just going to be one interval for my answer, starting and stopping point. When I see the greater, that's an or statement. So that's when I do 2 of them. So the first one stays the same. The second one, you flip the inequality and make it a negative. Just like when you multiply or divide by a negative, that inequality flips. So then we solve each of these. A graph isn't required here, but if it helps you, you can. Greater than 3 is everything bigger than 3. Less than -4 is everything smaller than -4. When I have an or, I'm expecting a union in my interval. So what would I put? Going from left to right. Then it's -4, union 3 to infinity. It's saying any number smaller than -4 or bigger than 3 would work. Is that okay? I just have a few left. What do we do first on this one? isolate that absolute value. So I'm going to add over my 1. Make sure you isolate your absolute value before you decide if it's an and or an or. You know, if you multiply by negative, it flips your inequality, so it changes. So now, is this and or or? Or, greater or than, this is an or statement. So the first one, you just drop your absolute value. Or, for the second one, you make it a less than negative 5. So if I subtract my 2, what happens when I divide by negative 7? Subtract my 2. Divide by negative 7 flips my inequality. Alright, picture is optional if it helps you do it. You have a negative 3/7 and a 1. Less than negative 3/7 is smaller. Greater than 1, that's everything bigger. So how do we write this? Good. You guys try the next one. Let's make that a less than or equal to. I haven't had any equal to. Less than is an and. So we do one big inequality. So first subtract your 6. So then we're going to put this between negative 8 and positive 8. So if you solve this, what happens now? Divide by negative 8, which flips these inequalities. Okay, if you don't like how that's written, you can turn it around. What do you do with the inequalities? Flip them. So this is just saying my x is bigger than negative 3/8, but smaller than 13/8. The equal to means what?
Brackets.
So it was an and, we get a single answer. Negative 3/8 to positive 13. Is that okay? All right. Let me ask you a few special cases here. So A, I have an absolute value equals 0. So typically we set it equal to a positive and a negative. Positive 0, negative 0, it's just 0. So we're only going to get one answer. So it is possible to only have a single answer. All right. B, I have an absolute value greater than negative 2. So why would you say that? Because we have what? A negative. And I told you, if you have an absolute value and a negative, stop. You don't really need to work it out. We need to think about it. So when it was an equal to, it was no solution. But we haven't talked about it with inequalities. So an absolute value is what kind of number? Positive. Is a positive number bigger than a negative number? Yes. When? Always. So what's my answer if it's always true? All real numbers. How do we do that using intervals? Negative infinity to positive infinity. You can pick any number in the world I can plug it in there and that statement is true. If you work this out, what happens is you have a greater than, which is an or statement, and when you go to graph them, they overlap and they cover the entire number line. So you could work it out and still get there. Okay, what about this one? Why? Right. We know this is positive. When is a positive number bigger than or smaller than a negative number? Never. So this one is no solution. How would you graph it if it's no solution? You don't. You just have an empty number line. There's nothing on it. How would you graph negative infinity, positive infinity on another one? The entire thing. All right. Is everybody good?
Yes.
Okay. So let's. Okay. That's all. Oh, one rate is matching. It's not that bad. Okay, also, I need your opinion on something. So, we are ready to go into chapter 2. We are actually skipping the first couple sections of chapter 2, and we're going to 2.3 next. And it's a big section. There's a lot of stuff in it. Would you guys rather do a quiz over just the inequalities and the absolute value before I throw more stuff in it?
Yes, please.
So could we do a quiz tomorrow over these two sections? What we have been doing? Yeah,
tomorrow.
How about the next day?
How about Thursday?
Thursday.
Just be like a game time.
So,
Yeah.
Let's negotiate.